Hello everyone and welcome to the final Shift Remote for 2020, the conference where we bring together the brightest developers online for you, our friends, our family, our incredible audience around the world. It's been so great having brought these to you so far this year. As ever, let us know there in the chat where you might be in the world. As you know, we've got about 2.5 hours together at around the hour-and-a-half mark. We're going to take a 5-minute break, which is just your chance to get away from the screen, grab anything that you might need before coming back here to join in and get stuck in to another incredible event. It's been amazing, as I've said so far. We brought you some of the best speakers around the world, and today is going to be no different. We've got so many more amazing speakers for you. Our conference, for those of you that might be new to it, I'm not sure where you've been, but we use the chat function quite a lot. It's a way for you to stay connected. We can also use that Q&A function as well, just for you to ask any questions that you might have about the specific event. But you didn't come here to see me, and I'm just your host, as you know by now. My name's Bilal, and I pop up every now and then. You did come here to see our incredible speakers. Before we get to that, once again, just a huge thank you to our sponsors at Infobip and Raiffeisen Bank, also at Microsoft, Autodesk, Microblink, Barrage and Azure Idea, as well as ICT Japania. We've also got our friends at Venture, Pseudocode, 5, Ars Futura, Nanobit Infinium Q, 9 Dots, Get by Bus, Aspira, Code Anywhere and Pluggy. Without you, none of this would be possible, so a huge thank you to our speakers. So let's get the show on the road and let's welcome CEO and founder of Shift and Shift Remote, Ivan Burazin.
And it is episode 12 of the Shift Remote series. So this is the last event in the series. I thank you all that have been staying in tune with us the entire series, and especially the ones that are still here, that have not, at least mentally, because most of us can't travel, gone off for some well-deserved R&R. I mean, all of us deserve some R&R for going through 2020. It's just been an insane year. On that note, and because of that, this event is going to be a bit short and sweet. We have some very cool speakers, but a lot less than usual because we feel that we all just need some time to relax. So it's going to be short, on the point, and the theme today is artificial intelligence. So we're going full circle. Started the entire series because of our AI event at the beginning of the year, and now we're ending it with an AI as well. So thank you again to all our sponsors that made this happen, that helped us survive this year, and thank you all for tuning in. I really do hope you enjoyed it, and we hope we continue the series next year. In any case, Shift will be back in 2021, even stronger than ever. So stay tuned. Happy holidays and Happy New Year.
Thank you, Ivan. And with that, let's bring up our first speaker, who's a data transformation product owner with a strong expertise in all areas of data-related products. We're talking automated data mapping. Let's welcome Josip Tonkovic.
Hello to everyone, my name is Josip Tonkovic. I am consultant from Azad Analytics, currently work in RBA Croatia as a product owner of new data architecture. I have 13 years of experience working in different projects on DVH, business intelligence and big data, and today I'm going to talk about possibilities of automated data mapping. Agenda of today's presentation is as follows. So we are going to start to explain you about new data architecture in RBA Croatia. Then we are going to talk a little bit about goals of this architecture, about challenges that are connected to these goals, about data integration, possibilities of automation of data integration, about artificial intelligence based data mappings, and we are going to finish with next steps that we are planning to execute in our bank. So this in front of you is a picture of new data architecture. I'm going to share some light regarding this picture. So on the left side you can see all sources of data that we are planning to ingest to our data architecture. The first layer of our architecture is data lake. We are planning to replicate data from source systems to data lake. We can do so in batch, real time, near real time. We can replicate structured and unstructured data, and we are planning to store raw data in data lake with unlimited history. The benefits of this approach would be that this data can be used at any time and it will be available even though our source systems will be offline. Also, that we can always be sure that we will have enough resources to process this data, and this can be scaled through requirements of our target systems, not through requirements of source systems. From data lake, we are going to load data to operational data store that already consists of banking data model. Please try to remember this, because we are going to reference to these steps multiple times during this presentation. So all data mappings resides in this part. They are generated from metadata and they are going to be executed by ODI. So from ODS we can load data to data warehouse. The difference between ODS and data warehouse is that ODS consists only of one series of data and can be loaded multiple times per day, while data warehouse consists of full history of data, and all data quality patterns and principles are applied to this data in GDVH. But that also means that any new development and maintenance of existing batches and pipelines are quite more expensive in DVH comparing to any other architectural part of our architecture. Also, GDVH is always built toward initial insights of how data in source systems looks like and about initial demands of our data consumers, but during the time both of these are going to change. What brings us to problem, what usual pain point of GDVH as a technology is that it's not agile and it's very hard to change anything after the initial development. And that is the reason why we also added Data Hub to our architecture. So Data Hub should serve as a complement to GDVH technology. Data Hub will apply business transformations to data that is already stored with deep history pattern. Data Hub can consume data or source data from GDVH or from data lake, both parts of architecture already containing deep history pattern of data, and that means that any development in Data Hub can be very agile. So let's say that we are going to build dimension of customer domain data. That means that we can start only with 3 or 4 attributes that are currently we are know that business users are going to use from the start, and then at any time add new attributes and rebuild the whole dimension from the scratch using data from data lake or GDVH. Also in Data Hub we can combine data again in real time, near real time, structured data, unstructured data, or forever possible data source of our architecture. We are going to expose data to business users through serving layer. That means that on the top of the serving layer we would like to build data glossary, and we can do it in any technology that suits that fits business requirements and needs. So for relational data we can use PostgreSQL, for real-time data Kafka, to search text files we can use Elasticsearch, for analytics Druid, or we can combine real-time and batch data by Lambda principle in Hive. Our architectural goals were to establish metadata-driven development, what can increase the speed of development and reduce time to market, because our developers can be more oriented and focused to business logics, versus in manual development they should think about many technical details. Also code will be more standardized, and this will also bring us data lineage. That means that some business transformations will be written inside of Excel, and from Excel we are already capable of generating any code and using it in our daily ETL pipelines. Also, our architecture will support agility. We already talked about that in previous slide. We would like to enable real-time. It enables advanced analytics, processing of unstructured data. Also, it's completely technology unlocked, so we are using technology that are almost all open source technology versus our previous architecture where we used products of Oracle, IBM, and providers such like that one. Also, it's cloud ready because we can consume data from cloud or send data to cloud APIs. And what we would like to bring is a new concept of data mesh. This is something very interesting, but speaking too much about that would break boundaries of timeline of this presentation. But what we would like to do is to democratize and decentralize our data architecture so different teams could be responsible for different data domains. So theoretically, car team could be responsible for car data from source system to serving layer, and that means that certain set of people with the best skills will know how to approach any kind of requirements that will be pushed to car data, and we will be faster in change, and that will mean that we could serve data at scale to our business demands. So, what is challenges of our architecture? Although architecture consists of only data warehouse, now we added more areas. So new architecture consists of data warehouse, data hub, and data lake, and that means that it's quite more complex and more sophisticated. And the question is how fast we will be to bring new functionalities to our new architecture, and will time to market will be better than with the old one. So what we will try to do, we try to automate all aspects of our architecture that we see that we are capable of, and that means that we would like also to bring automatization to data integration and data mapping. Usually when we speak about data integrations, we think of combining data, residing in different sourcings, and providing user with a unified view of data. That means some kind of data harmonization, bringing business values, unifying the fields, definitions, etc. The core of this data integration is actually data mapping process. That means process of matching fields from one database or one schema to another, usually from source to target. Artificial intelligence and machine learning can bring new values to these data mappings in two ways. First, mappings can be improved. Usually, developers try to develop data pipelines manually by adding mappings and by adding rules of data quality. Building such a network of complex data quality rules usually meant that rules will be handled one by one, and that will be done independently. And usually after some time this network becomes too complex, and it was at the end impossible to maintain such network and add any new rules. So by using machine learning, we could train our model using signals like some kind of technical constraints or business knowledge, and then all problems with data errors could be treated as one in a single view or single picture. So then that means that we could recognize phone numbers, we could identifying and correcting typos, the duplication, erroneous, and missing values. One example from Python is that by using Python data library, we could perform the duplication of data by training models. The only input that this library needs is some kind of information, what attributes of entity should be used to identify unique values. So this is the only input that some domain experts should be set, and after that model can be trained and can produce results. Also, where artificial intelligence and machine learning could help us is that mappings can be automated. So artificial intelligence based data mapping methods that could be used to implement this are, we could compare the content from source and target schemas, and then we could train the model based on that knowledge, and model will be able to predict the target schema after new source schema was added. We could add some kind of metadata feature or features to the actual values on source and the target, and so model will be able to be trained based on these features. Also, we can use names to train model, or we can train model but by using already mapped data. That could mean that, for instance, if we already use customer data from source systems and map it to customer data of GDVH, based on that data and metadata, we could theoretically be able to produce mappings automatically if we are going to send data from our source systems to CRM. Challenges and limitations that could be met on these approaches are that names are not connected always to the values. Sometimes names point to something semantically totally different, or generic mappings where different data values are combined are not easy to implement. If data mappings and transformations are too complex, it wouldn't be realistic to expect that this automatization will be able to detect them and to create them automatically. Data changes formats between source and target also can be too complex to be automatically created, so that means that also some kind of training or some kind of human interaction should be made. We found a tool on the market that already can do this automatically, and that is always a benefit because then learning curve shouldn't be so hard, and you don't have to have people with some kind of technical skills to implement such a model. Also, these tools are usually scaled to work with big volumes of data, and they're already incorporated in some kind of data integration platform. So this Adeptia tool works in a way that draws from machine learning of existing metadata elements, source and target sample data, and data maps information. And in the first steps, it trains a model and builds a neural network. And then in second step, based on the knowledge from the first step, by adding a new schema on source systems, it can predict the mappings that should be made, so the data could be mapped to the target schemas. These mappings are predicted by using some kind of accuracy, and they are classified to high, medium, and low. And then in the last step, business users should review these mappings and either accept or change the suggestions. There is a use case from the real life where Adeptia tool was used for some retailer, and in this use case only first 30 mappings should be was made manually, and then all the remaining 1300 mappings were automated, and the result was that the whole process was speed up by factor of 10 to 15. So we think that this is kind of cool, and it can be used in our organization as well. The second possibility of using machine learning and artificial intelligence is to build machine learning custom models. These models will be harder to be implemented, but they can be more customized toward our needs. As you can see on this slide, our idea is not to map our source schemas directly to target schema. We would like to map source schemas first to some kind of intermediate schema, and from intermediate schema to target schema. The reason for this is that if we map A, B, and C source schema directly to the target schema, and something changed to this target schema, all connections from source to target should be adjusted. By introducing intermediate schema, then only this mapping from intermediate to target should be made, so the whole system could work after these changes is made. Three algorithms that could be used for these models are shortest distance, maximum flow, and data value. Shortest distance works in a way that tries to connect to two nodes in a graph with a path that will have the lowest cost, and maximum flow vice versa works in a way to try to optimize the traffic by using the existing resources. Problem with shortest distance model is that can only predict values based on the pairs that were used for training, so any kind of unsupervised uh, learning is not possible with this algorithm. So it can only predict target schema based on the pairs of source and target schemas that were already inserted into model. Maximum flow, on the other hand, can also bring new knowledge, so it will provide us with a bigger set of results, but we are not sure that these results will be more accurate. Data value will probably be the worst model among these three, but can predict some values and the results that won't be possible to be predicted by first two models. What could be automated? So we are currently doing the migration from our old ETL tool to new one, and we try to measure how many of our mappings could be automated by these principles. 20% of our mappings already uses only constants, and we are sure that this could be automated. 30% of them are using one-to-one mappings, and is something that already Adeptia could do, and probably any kind of customly developed machine learning mechanism could also do as well. 20% of our mappings are reformatting data, is probably something that we could implement, but it will be harder. And 30% of all transformations are too complex to be predicted with some kind of machine learning algorithm. So our goal is to solve this 70%, and we think that this could speed up our process, especially when we are trying to add new sources that we are not aware of currently. And in the end, next steps are, we would like to do the minimum viable product of a DepTI map, where we would like to confirm hypotheses from their white paper and try to use them in our use case. We would like to try to implement custom machine learning model as well to build something that will be more oriented to our use case in our bank. Then if we will be able to succeed in first two cases, we would like to apply these models to GDVH mappings, and we would like after that to apply models to all data integration use cases. That will be all for today's presentation. Thank you very much for your attention, and I hope that you enjoyed it. Bye.
Thank you, Josip, and let us know there in the chat if you enjoyed that. Remember, the hashtag for this event for all social media is the hashtag ShiftRemote. Let us know how you're feeling for our final one of the year. Our next speaker, though, is a computer science major, data scientist and software engineer who also likes to work out and enjoy the music, which is why he loves us here at Shift. He's currently at Ars Futura, and in this talk we're talking about facial recognition. Let's welcome Luka Dolcic.
Hi, my name is Luca. I work as a data scientist in Ars Futura. The next 10 minutes, I'll try to explain you how modern face recognition systems work. So let's get started. Face recognition is a pipeline which consists of three parts: face detection, feature extraction, and face classification. So you get an image on the input, and the first step is detecting face in the image. After detecting face, we crop it out of the image and extract features from it. And finally, we classify face based on those features. In this talk, I'll focus on the core part of the face recognition, which is feature extraction part. Most of the modern face recognition systems use FaceNet or FaceNet-like networks as feature extractors. So what is FaceNet? FaceNet is a deep neural network used for extracting features from an image of a person's face. It was published by Google scientists in 2015. FaceNet takes image of a face's input and outputs face embedding. So what is face embedding? Face embedding is a vector which encodes face features. Ideally, face embeddings of images of the same people are very similar, and face embeddings of images of different people are not similar. So to make this more clear, let's visualize it. Since embedding is a vector, we can interpret it as point and coordinate system. For demonstration purposes, let's assume the face embedding has only 2 dimensions, so we can plot it in 2D coordinate system. Okay? So let's plot this face based on its embedding. It looks something like this, and let's also plot a few other faces. So as you can see on the slide, images of the same people are grouped together, which means that their embeddings are very similar. So now that we visualize this, the question is, how do we classify a person on some unknown image using face embeddings? Okay, so let's show it in this example. Here's an unknown image which clearly belongs to the male person class. So how do we classify it correctly? Well, there are several ways of doing this, but one possible way will be to use the nearest neighbors method. So we calculate face embedding of this image, and since it clearly belongs to the male person class, when we plot it, it should be close to that class, as you can see. And then we calculate distances between the unknown image and known images. And as we can see here, unknown image is clearly closest to the male person class, so we classify it as being part of that class. Its nearest neighbors belong to the male person class. Okay, so this is one way of classifying people using face embeddings. But really you can use any classifier you want for the classification part. For example, we can train logistic regression on face embedding of the known images, and then logistic regression would learn some boundary between these classes, which would probably look something like this. And then when you get a new and unknown image, you first calculate face embedding of that image, feed it to logistic regression, and get the class. That's it. Okay, so this all looks great, just feed the image through FaceNet, get the magic embedding, and get the class in any time, just use any classifier. But how is this embedding so good? How does FaceNet learn to produce such good embeddings where face similarities are preserved? And what do these numbers in the embedding even mean? Let's try to explain this by digging deeper into FaceNet training process. At the beginning of the training, FaceNet produces random vectors for face embeddings, which means that faces are scattered randomly when plotted, as you can see on the slide. And FaceNet learns in the following way. First, it randomly selects an anchor image, and then it randomly selects an image of the same person as the anchor image, which is positive example, and then it randomly selects an image of a person different than the anchor image, which is negative example. And finally, it adjusts its weights so that the positive example is closer to the anchor than the negative example. And then we repeat this process many times. We repeat it until the images of the same people are grouped together and far from the others. So I hope now you get a better idea on how FaceNet learns to produce face embeddings which are similar for the same people. They're enforced to be similar by the training process itself. But how do we explain the numbers in the embeddings? What are these numbers? Is this nose length? Is this color of the eye? Something that seems important for recognizing people. Well, the truth is that we don't actually know. Now, during training process, FaceNet is trying out many different combinations of features until it finds the ones that work the best, the ones that separate different people. It's really hard to interpret these numbers in the embedding, but we're pretty sure that something like nose length or distance between eyes are hidden behind these numbers because we can intuitively assume that these features are important for distinguishing different faces. But we cannot nail the exact features that FaceNet is using. Okay, so that will be all from me. I hope this was interesting. I also wrote a blog post about face recognition which explains this in more detail. Link and QR code are on the screen if you're interested in reading it. That will be all.
Thank you, Luca, and we're moving so quickly through our speakers. If you're having a good time, as ever, let us know there in the chat. We love it to hear from you. You know I say this all the time, but our next speaker is the head of product strategy and developer relations at Tigergraph. They bring a strong academic background as well as decades of industry experience with a PhD in computer science. Let's give a warm welcome to Dr. Victor Lee.
Hi, I'm Victor Lee, Head of Product Strategy at Tigergraph, and I'm here today to talk to you about smarter AI with analytical graph databases. So, why do we want to talk about graph databases at an AI conference? Well, because Gartner, one of the top tech industry analysts, has said that graph analysis is possibly the single most effective competitive differentiator. The single most effective way to differentiate yourself from your competitors for organizations pursuing data-driven operations and decisions. And AI people are clearly working with data and making decisions, and it seems like the intelligent thing to take a look at graph databases and graph analysis. So here's our agenda for today. It's going to be a quick 20 minutes. So what is an analytical graph database? Why graph and AI? And then a very quick look at 3 basic approaches for graph and AI with some use case examples. Those 3 ways are unsupervised learning, feature enrichment from graph features, and finally in-database learning. So why graph? Well, first of all, what is a graph and why graph and AI? Well, in the picture here, we have a graph. It's a collection of nodes, data objects, and edges, or the relationships or connections between those nodes. And you see that they have descriptive names, so which gives some idea of what they mean. So graphs are very illustrative and very semantic. And so because you're storing your connections as data, you actually have a much more natural way of expressing things because it's semantic, it's embedding intelligence right from the beginning. And it's a very natural way to connect different data sets because you just connect them. Connections are already part of your infrastructure. It allows you to ask deeper and smarter questions. Why? Well, first of all, the technology behind graph databases makes following those connections much more efficient than any other type of database, definitely much faster than in relational databases. And as we said, the relationships are semantic, so you can ask questions directly of the graph of things that have meaning to you. And because of the performance of following those connections, you can, again, search farther and wider than you would be able to in other databases. A lot of algorithms have been developed specifically for graph. And then we're going to talk today, of course, about graph-enhanced machine learning. And finally, when you get into AI and machine learning, one of the challenges is for your model to explain how and why it works. And again, going back to the semantic nature of the graph with these relationships that describe what they're about, if you have features that are based on these very semantic, easy to understand topologies and patterns, then you are going to have an explainable model. And also, anyone can just look at this and understand what it means. So, talk quickly about 2 major types of graph databases and then analytical graph databases. So there are 2 major families: semantic RDF knowledge graphs, where you have individual facts, which are triples of subject, predicate, object. You also have ontologies, which are conceptual hierarchies and trees, as well as rules to describe the meaning of the data. And then these type of knowledge graphs, they're very good for pattern matching, and they're good for logical inference, drawing conclusions or saying if A and B are true, then C must also be true. On the other side, you have property graphs, where we have, like we saw, node and edge type objects. They tend to be more similar in concept and design to traditional databases. And because of that, they are higher performance for if you have a large amount of data and you're interested in a lot of transactions or more complex analytics, property graphs are probably your better choice. They can also do pattern matching. You have your choice of either schema-free or schema-based. Schema-based is like relational databases where every table has a particular type of structure. And the advantage of schemas is that they really allow you to model exactly how much you want and no more, and to do this sort of application-specific tuning. Now, both kinds can be transactional, which mean they handle, things like transfers of money, small updates or small reads, and with guarantees that you can have lots of transactions going on concurrently and they don't interfere with each other, and that they are guaranteed to either happen or not. Banks love transactional databases. And then there are analytical ones where you're more concerned with the computation, so the analytics may be more complex. You're less concerned about the transactions. Of course, there is overlap. You can have databases that do both, though they're sometimes called HTAP, hybrid transactional analytical processing. Now, my company, TigerGraph, where do we sit? We are an analytical property database, also transactional, but especially good at analytics. I'm going to talk today, again, into the graph and AI, and give you a few real-world cases. These are all selected from our customers. So, healthcare real-time recommendations of one of our customers, one of the largest health insurance firms in the U.S., built what they call a graph brain with 1.3 terabytes of data, and they use this for real-time care recommendations. So they're both improving healthcare and lowering costs. So that's very important in the U.S. with the private healthcare industry. Industrial supply chain. This is actually a European company, and they're using our TigerGraph for advanced supply chain analytics to make both strategic and tactical decisions. And what they noted is computations that used to take 3 weeks now take 30 to 45 minutes, and they're saving tens of millions of dollars per year. And third, we have several customers in the financial industry. One in particular, like several others, are using it for real-time fraud detection. They've integrated multiple tools and have been able to merge them into one master graph application. And they call what they've been able to do with the graph, they've described it as magical, because you get real-time and visual results. And for fraud, even though you can do automated detection with AI, it's usually only has a suspected case. And for larger banking transactions, you actually want to do some follow-up investigation to dig deeper. Not like credit cards, usually just simply automatically accept or reject, but with larger transactions, you need to investigate. So our first type of using graph to help with AI is analytical queries and graph algorithms. Graph algorithms are things like finding shortest paths, finding natural communities, ranking. PageRank is actually a graph algorithm, and closeness and betweenness centrality is another type of ranking. Similarity, if you find one node of interest, and based on its properties and the properties of its neighbors and who its neighbors are and how it's connected to those neighbors, what other nodes are similar, having the same types of neighbors, similar properties. So it's actually a very complex and interesting problem. Frequent pattern discovery. Without giving the graph anything in particular that you're looking for, And notice this is sounding like unsupervised learning, where you're just given some data and you're asked, tell me something interesting about this data. So similarity, finding similar things, is unsupervised. What I was going to say, frequent pattern discovery. Do you see little patterns, little structures that occur a lot, perhaps more than you'd expect? All of this unsupervised learning, of course, it can be very valuable for anomaly detection, just trying to understand the world better by understanding what's common, understanding who's most important with this ranking and centrality. Again, without having to train the data set, just using these standard graph algorithms, you can learn quite a lot. Case one, back in the healthcare industry, how to find the most influential provider, medical provider, in a particular region for a particular medical condition. So we're going to analyze the full graph of interest. So first, we're going to filter it down to the particular medical condition in a particular region. Then we're going to do some referral analysis. So we have different doctors, patients, the prescriptions they make, all the different medical procedures. We're going to focus on referral relationships, where one doctor refers a patient to another doctor. And in some of the real world data we've dealt with, that data wasn't always directly available, but you can use the graph to infer those relationships by saying, patient saw Dr. 1 at a certain time, saw Dr. 2 at a later time. There was, close enough in time so that it could be a referral, and the condition that they saw them for was related, so makes sense, there was a referral. So you can actually add an edge to the graph to represent that referral. So now we have a doctor-to-doctor graph with referral edges. And when you have this type of graph, one entity pointing to another of the same type of entity, you can apply the PageRank algorithm. And what you'll find out is the entities with the highest rank are the most influential. We can then do looking and see who are they influencing. So we know who is the most influential. Now we do a community detection. And community detection is looking for a relatively high density of interconnections. And then as you go outside the boundaries, the boundary is defined by where you start to see a significantly lower number of connections. So there's relatively high number of connections within the community, and then it drops off outside the community. And so this tells you who is this doctor influencing. So this can be used for multiple purposes. If you are selling a medical product, you may want to target your marketing at that doctor. If you are trying to promote good healthcare practices, if you are in public health, you know which individuals you would particularly want to convince, because what they do will influence others. So it's really important in a lot of industries. It can be obviously important in other cases. Another use of algorithms, this case similarity algorithm. This is a dashboard that represents one particular patient's healthcare journey. And if you just click this button in the application, it will find other patients in the health group who have a similar, not identical, but similar health journey. And how does it do that? So if you break it down into a graph where these large orange nodes are patients, and they are connected to these various blue nodes, which represents properties that they have. Those properties could be some procedure they went, a doctor they visited, a diagnosis they had, anything related to their patient journey that the analyst decides is important. And so everything you're connected to is a feature. There can be a weight or some sort of number indicating the strength, importance of that relationship. So A has relationships with W, X, and Y. B has relationships with X, Y, and Z. So they overlap with these two. And then there are a couple of different similarity algorithms you could apply. This is an example of cosine similarity where we do square the sum of these weights, square the sum of those weights, and then square, do the product, basically the inner product of where they overlap. And that's where you find A and B. So what we're trying to see is there a lot of overlap, and are these weights high? So if there's a lot of overlap between A and B, and the weights are high, then you get a high similarity score. And that's why that's actually a graph problem. Go very quickly. Now we're talking about case 2, a second way in that graph can help with machine learning and AI. And when you do now supervised learning, you need features for your training data. And as we know, the richer training data with the more relevant features you have, the better success you will have at developing a good model. And so another customer here, China Mobile, they were trying to do an anti-fraud detection system. So what we constructed was a phone-to-phone network with each connection is a phone call. And we worked with them to identify 118 features just on this call-to-call network. And we looked at like how often do you have or how large a stable group do you have, and who is in that stable group. Stable means over time, consistently over time, you've called this person. And then within that group, do they call each other? Then that's an in-group community. There are things about, do people call each other back within a certain amount of time and a certain frequency? And then is there sort of a chain? 1 calls 2, calls 3, calls 4. Do they loop back and form a closed loop like that? And those are 4 or 5 examples. There are actually 118 of these. They had 15 billion call records, 600 million phones, extracted, I said, these 118 features, labeled past data with whether it was fraud or not, fed this into a machine learning system. And now what they do is in real time, when a call comes in, so if this call, if this is the person calling you, they extract these features to see whether those features indicate an unwanted call. And they can do that in tens of milliseconds, so that before you even decide to answer the call, you can see an alert on your phone if that is suspected fraud. Great little application, which has gone into use in a lot of cases. I think we just looked at that. And again, this is an opportunity. We're using machine learning and AI, but because we're using graph and we're using those features that I described as having some sort of meaning, real world meaning, your stable call group, your in call group, your return call, your model has explainability. So when you produce a model, you can say why a person was rejected. And that's great also for anti-fraud. It's great for medical recommendations. It's great for product recommendations. In a lot of cases, neural networks are great, but they don't give you a very explainable results. And now that we just talked about neural networks, we're going to get to case 3, in database machine learning. Third advantage of graph and AI, or third way to do it. And here, the advantage is basically simplifying and streamlining your machine learning pipeline. So if you're bringing your data directly into a graph, you do your data cleansing, you do your graph feature extraction, which we just talked about. Now you do your machine learning while the data is still in the graph. You might use a traditional method. You might use one of the newer graph-based method. But the thing is, you didn't have to export your data out and back in. It was right there. So, and then when you deploy your model, you just apply it directly in the graph. So it simplifies things. Now, can you do this with just any analytical graph database? This is perhaps the most challenging thing we've talked about. It is something that is reasonable and plausible with TigerGraph because of its high performance and scalability. What you need is a high performance graph, which is usually what we call a native graph. That means it's designed from the bottom up to be a graph database. And you want that property graph model rather than the knowledge graph model. Again, the advantages we talked about, the data is right there. it's coded in the graph, and it'll automatically scale out and scale up. TigerGraph offers real-time updates. So as the data changes, it's all quickly seen in the graph. You can quickly update your model. And most importantly, our query language is actually Turing complete, which means that you can implement algorithms directly in the query language. And that's something you can't do in a lot of cases. So I'm going to go very quickly through this example. Here's one of our real world examples. If we run out of time here, you can look at it yourself. We have a webinar, Graph Guru episode number 28, which describes this. And also on TigerGraph Cloud, you can try one of our free starter kits, the one called Low Rank Approximation Machine Learning version 3. Basically, we have, I'm going to skip this because, we just have movie recommendation data. And what we have is the Movie Lens data set with 100,000 ratings, 40,000 tags, 1,000 users, and 17,000 movies, which they rated from 0 to 5. And there are several different machine learning models you could apply: collaborative filtering, content-based filtering. We're using here the latent factor technique. And so again, we have movies, they each have tags. We have users who have different preferences, and a user rated a movie with a certain score, and we're trying to predict scores like this. Alice didn't see Iron Man. We're trying to predict what she would think of it. And in the latent factor model, we form these matrices. So we have different persons, and they have feature vectors. And we also have the movies, and they have feature vectors, or latent factor model. And what we're trying to do is, these would be the predicted scores. You see that Alice did not actually see Toy Story or Cute Puppies of Love, but based on learning these weights, what we're trying to do is learning the best weights here. We would then predict that Alice would rate Cute Puppies of Love with 4.5, and we predict she would not like Toy Story very much at all. Lastly, I want to talk very quickly about a couple exciting new developments in machine learning for graph. One is graph embedding, and the other are graph-based neural networks. So, wow, I'm skipping over graph embedding. Sorry about that. But it's basically, it's a way to generate feature vectors of a graph automatically, and then which then prepares it for training. In a conventional neural network, you have an input layer, you have an output layer, and you have one or more hidden layers with these connecting this mesh of matrix of connections, and you can actually describe these connections as a matrix. And to go from each layer, you can think of it as matrix multiplication. What's different about graph convolutional networks is we add an extra step into the matrix multiplication, where we actually take the so-called adjacency matrix. If you know, every graph topology can be described as a matrix where you have input vertices, output vertices, and if there is a connection between them, then you fill in that cell in the matrix. So that's the adjacency matrix. So to go from each one layer to another, not just multiplying by the propagation matrix, we also multiply by the adjacency matrix, and that takes into account the pattern of connections in the graph. And again, this is neural networks. You just start off with a random initialization. You know your input, you know your desired output. You learn what weights will make sense. So we don't know what effect the adjacency matrix ahead of time is going to have, but it's there. It's embedded in the neural network. And so whatever importance it has will be taken into account of. So lastly, again, as we said, TigerGraph is a graph database. It's a property graph database. It's one that's particularly good for analytics. Its design makes it better than its competitors at doing more, analyzing more links deeper with the same amount of, given the same resources, it'll be able to search deeper in the same amount of time. We'll also handle scale for large amounts of data, and more successful AI applications require more data, so that's important. And again, the query language and the both support for both transactional and analytical workloads make TigerGraph great for in-database analytics. So thank you so much for your time. This was really faster than I normally go. So graphs are a great natural data model. They provide richer data. You can do AI and machine learning in both unsupervised feature enhancement and some new graph-based neural network techniques, and they provide explainable AI. So thank you very much. I'd be happy to take your questions.
Thank you, Victor, for such an insightful presentation. Let's just hit a few questions we have for you, and we're going to hear your answers. What do you think, and for our users or people that adopt what you were saying, how can one know if they have a good use case, for example, for on this topic?
Right, that's a great question. If you're not already using Graph, how should you know whether you have an appropriate data set or an appropriate use case? The first thing is, are you trying to understand better how one thing correlates or one thing relates to another? Or are you trying to see, I know about these two things, like one person and a transaction or a product, and you're trying to see, are they interested or are they somehow connected? If you're trying to discover that, then you probably have a good use case for Graph because you are interested in the connections. The other is, even if you don't think you have Graph data, just if you have, again, entities that have lots of features, and they might, you want to know if they have those features in common with something else, and those features might be, for example, where I live. That's actually a feature, where I live, or what my occupation is, or what I like. Those are, and if you start to think in those terms, you also, and again, if the questions you want to ask relate to those things, then you may very well have a good use case for Graph.
Perfect. And when you do this and when you manage this kind of data, what would you say and what would you recommend, and also what do you use? What sort of machine learning platforms do you connect to?
Right. So TigerGraph has a Python library, which makes it basically easy to connect to any any common machine learning platform you have, whether you're using PyTorch or TensorFlow or just something through a Jupyter Notebook. Almost everybody is using Python now. So we have on our website, we have some on our dev.tigergraph.com, which is for developers. There are some get started guides and some examples of machine learning that you can take a look at there.
Perfect. Thank you, Victor. And then maybe to close with a simpler, less technical question is, we have a lot of younger audience on our side and on our platform and following Shift. What would you recommend them if they want to go into this field, if they want to manage this kind of data? How would they start off, and what career path maybe would they take?
Sure. I think if you are interested in coding, obviously, just getting involved in some sort of open source project is a great way to get really involved in something real. And you can start small. You can find something that's to your liking, that doesn't seem too complicated. Something that's usually on the user front end is one way to get started. But if you're really interested in, say, data analytics and graph databases, So first of all, on our website, we have training and tutorials. You can go to the resources area on our website to see all different ways to learn about graph, not just about Tiger Graph, but about graph analytics in general. Obviously, data science is hot. There's all sorts of free resources for getting started in data science. There's a free version of Tiger Graph if you want to play with it. Either Tiger Graph Cloud, TG Cloud has a free version, as well as our downloadable version you can also get for free. So there are lots of ways to get started. We have a community where you can chat about things. Again, not just Tiger Graph, but graph in general. So go to community.com.tigergraph and you can just start chatting with the community and ask your questions there.
Perfect. Thank you, Victor. We're unfortunately running out of time. It was a great presentation and insightful answers from your side. Everyone else, please check Tiger Graph, as Victor said. And it was a pleasure to have you at this shift. Hopefully, soon in the coming, let's say, months and years, we'll have you on one of the shift events in person. Thank you, Victor.
I would love to come in person. Thank you very much.
Thank you, Victor. And with that, this is our break. We have 5 minutes here for you to grab some snacks, go to the bathroom, grab yourselves a drink. This is a part in a virtual conference where I wish we could be having a drink together, but unfortunately that's not possible. But grab your drink and come back here and we'll see you again in just 5 minutes' time.
Uz moja RBA mobilno bankarstvo prati stanje svojih računa, plaćaj putem fotonaloga, upravljaj svojim troškovima ili šalji novac svim kontaktima iz mobitela uz ClickPay opciju. A od sada svaku transakciju iznad 300 kuna provedenu kreditnom karticom možeš podijeliti do čak 24 rate. Doživi taj RBA osjećaj. Uz moja RBA mobilno bankarstvo prati stanje svojih računa, plaćaj putem fotonaloga, upravljaj svojim troškovima ili šalji novac svim kontaktima iz mobitela uz ClickPay opciju. A od sada svaku transakciju iznad 300 kuna provedenu kreditnom karticom možeš podijeliti do čak 24 rate. Doživi taj RBA osjećaj. Uz moja RBA mobilno bankarstvo prati stanje svojih računa, plaćaj putem fotonaloga, upravljaj svojim troškovima ili šalji novac svim kontaktima iz mobitela uz ClickPay opciju. A od sada svaku transakciju iznad 300 kuna provedenu kreditnom karticom možeš podijeliti do čak 24 rate. Doživi taj RBA osjećaj.
Welcome back, everyone. I hope that you had a good break and managed to get the snacks that you need and the drink that you need, the fuel that you need for the last half of this Shift Remote conference. As ever, use the hashtag Shift Remote to stay connected with us on all social media platforms. But I'm going to introduce our next speaker, who has over 17 years of experience in the financial and IT industry. They've got degrees from the Institute for Manufacturing at the University of Cambridge and the University of Paderborn. They're a certified ATOS expert in data intelligence domain, and they're especially interested in developing ethical and explainable intelligent systems. Let's give a very warm welcome there in the chat to Helena Librenyak.
Hi to all. It's a great privilege to be part of the Shift Remote conference and to talk about this very important topic. My name is Helena Librenjak. I'm working in Atos and I will give you a talk today about ethical design of intelligent systems. But before we start, I would like to ask you to imagine that we are now in year 2030 and that you are returning home from your business trip. While still on departure airport, you order your Uber Autonomous X drive that picks you up precisely as you land at your destination. You have also in the same time given command to your smart home to heat up the house. Your Gamma chef will finish your favorite dinner just in time as you enter home. Your Rosie the robot has set up the table and opened your favorite wine. While Alexa shuffles the music, your favorite all-time hits, you can hear someone banging on the door. As you walk up to the door, open it, there is a police officer standing in front of it. And for the sake of the argument, let's say that you are Mike Smith. The officer asks, "Are you Mike Smith?" You politely confirm and ask, "Yes, how can I help you?" And without any further discussion or explanation, he puts handcuffs on you and starts saying that you are under arrest for grand theft of the bank this morning. As you walk to the car and drive to the police station, you understand that police has implemented new face recognition system. This system has, based on the surveillance pictures and images from the crime scene, identified you with 95% of accuracy as the main criminal. You start to defend yourself. And because you have the digital footprint, after hours of discussions and proofs like your Uber receipt, boarding pass, your Google Calendar, you made them understand that you are not the guy that they are looking for. Even though the story that I have just told you is an imaginary one, it's not a science fiction, because the real potential issue is already in front of us. The technology behind the scenes already exists. We have seen autonomous vehicles being implemented and tested. Many face recognition already in place. Humanoid robots in development. All of these technologies are entering our lives. Evolution of technology is growing rapidly, and in order to avoid consequences of reckless implementation, we need to think about and understand how we are using this technology. Today, we are already facing real issues that we should be worried about. There are ethical issues, not imaginary ones, that I have just told you about. There are systems that discriminate women, HR systems. There are facial recognition systems that show bias against people with darker skins. There are systems that are unfair to the people with lower income, as well as there are systems that fail to recognize vulnerable group of people. I'm sure you have already been aware of these issues, ethical issues, and the results of implementation of technology in an ethical way. There has been a lot of news articles about it, but if you're not aware, let me share a few examples with you. First of all is Amazon. Amazon has created a tool in order to review resumes and shortlist the right candidates in their recruitment process. This system was supposed to speed up the activities in Amazon, review hundreds of resumes, and identify the top talents. What they have realized after 1 year of using this system is that it is biased against women. Tool has simply rejecting resumes that has included word women in it. Another example is again Amazon. Don't get me wrong, I don't have anything against them. But they are first on the frontier, so we can expect these issues coming at them as well. Face detection technology that Amazon is marketing to law enforcement often identifies women, particularly those of darker skin. These incidents prove that even though machines and artificial intelligence can go a long way in making things and tasks of the organization better, help and to save time and costs, their decision and results cannot be blindly relied on. MIT has also done a review of the existing systems, not only from Amazon, but also from Microsoft and IBM, and have come to the same conclusion related to their applications. One of the most quoted situation is about system used by the American criminal justice, which is a tool that is creating risk assessment on the people who have committed crime. It's calculating risk score to identify whether they will reoffend again. The people with the higher score have tendency to reoffend again, and with lower none. What the system showed was a bias against people with dark skin because it identified them as people with higher risk scores. You might ask yourself how this is possible. How machine learning models, AI, is doing this kind of unethical and biased results. They should be neutral and objective. And they are in their core because they are not living human beings and they are without prejudice. But what we forget is that they are products of the human beings and our culture. And as such will always show bias. System based on AI use millions of data from which they make predictions. And in that data, there is culture embedded in it, our unintentional bias. The human bias that we have just mentioned exists in our culture. Problem lies when we train system based on observations coming from the real world. Very often, data are created by human decisions. Unintentionally, we code our bias, our prejudice, our wrong decisions in our algorithms. As we know from our own experience, we are often driven with illogical and unfair views and attitudes against other people. Well, the real problem solver or the solution for this problem lies in actually correcting our own culture, our own way of working, which is rather difficult to implement. I think you will agree with me. But what we can do is that we can make sure that during the development of the models, of the algorithms, we understand the data, we probe algorithms to bias, we try to measure fairness of the algorithm. There are existing techniques that can help us understand how the data was used, how the decision was made, and in order to act accordingly. But this debate is really not from yesterday. I'm not sure if you're aware of the experiment that MIT performed a few years ago. It's a model machine online experiment, which was delivered on 10 different languages. 233 countries participated in this experiment, and they have collected 40 million valuable decisions in critical situations. We could spend hours talking on this experiment, but I will try to summarize it and to provide a conclusion to you all, and also I would encourage you to make it yourself. Experiment goes something like this. You are a passenger in a self-driving car and something went wrong. Your car started speeding towards a big block on the road. If it continues straight and crashes in the block, passenger in the car will instantaneously die. But if you turn left, your car will run over a group of people, a group of pedestrians, and kill them. What is the decision that car should make in this situation? Should the car be programmed to take care of its passenger, or should the car sacrifice passenger for the greater good? What if you have a situation like I have presented you here on the screen, that if you continue straight, you will kill elderly people, some younger passengers, as well as an animal, a dog? And what if you turn and then face yourself driving to kids, a pregnant lady, and a doctor? What would be the decision here? There are different combinations in the survey: old people, young people, babies, kids, animals, people crossing on unmarked parts of the roads. And these so-called trolley problems have a new meaning in the world of AI-based systems. So, what was the conclusion of the experiment? The conclusion was that there is no universal ethics. In general, human life is perceived as more valuable than the animals, as well as larger groups of people and younger people compared to the smaller groups and older people. Even though results really vary from region to region due to different cultures and moral views, we could assign them to 3 different areas: East, West, and South. Civilizations and the countries on the East value more elderly people compared to the countries on the West and the South, where young life is more valuable. Interesting results are related to pedestrians which break the rule and also cross the streets where there shouldn't be. In the poorer countries, where laws and regulation are not functioning properly, people accept that and they are more tolerant to this misbehavior compared to the countries where there are strict laws, there are functioning laws and regulations, and where there is a higher GDP. With progress of the system based on AI, this topic will be a burning issue to resolve. Most of the people accept that ethical criteria has to be programmed in the AI in order to make proper decisions. But utilitarian approach is not good enough. There was another survey that has been delivered by the car makers on a similar topic as we just discussed. They asked their potential customers, would they buy their car if the car is willing to sacrifice passenger's life for the greater good? And of course, everyone said that they would not buy that car, that they expect that the car is going to protect their life. If we would take this problem to a little bit different context than the one that MIT has given, for example, let's think that we are in the hospital, that we are a doctor, and that we have 5 critically ill patients in one room. Each of these patients need either a liver, a heart, a kidney, lungs, or pancreas to survive. And in the room next door, there is a perfectly healthy young boy who just had his arm broken. Should the doctor even think about using the organs of the young patient and healthy patient to save these 5 human lives? I think you will agree with me that no life has less importance than the lives than others. So the problem here is very difficult to solve. But whatever we read and watch in science fiction, books or movies, the real risk is not that AI is going to become conscious and turn against humans, like we have seen in Terminator or Matrix. The real risk is that AI will diminish value of human life on a pure number without respecting human values and principles. Therefore, our responsibility is to set up boundaries of AI, assuring that these most prospective technology respects ethical criteria and puts human in the center. We have talked about issues, and logically, here comes the regulation. We have identified few ethical problems which have been amplified with implementation of AI. And regulation is something that different governments, different countries have identified as a need in order to in some way control the systems that are based on AI, especially in decision-making process when it concerns human lives and human fates. European Union is not the only one in these initiatives. Leaders in artificial intelligence, America and China, have also identified these problems and are thinking of going into the direction of setting rules, guidances, laws for responsible artificial intelligence. And they are not the only ones. Global vendors that we have mentioned recently have also understood this after failure of their systems, and they started promoting ethical standards as well as seeking for regulation, from my point of view, primarily for their own benefit. But let's focus on what has been done so far in Europe. European Commission has organized a high-level expert group on AI, which published recently a guidelines in creating trustworthy AI. These guidelines are not regulation, they are not law. They do not oblige any of the countries to behave like that. They are there to help companies to create systems that are reliable and trustworthy, which in the end will assure greater acceptance and implementation of AI-based systems. According to the guidelines, trustworthy AI should be, for one, lawful, respecting all applicable laws and regulations of the country, for example, GDPR in Europe. Second, they should be ethical, respecting ethical principles and values. And the third one, they should be robust from the technical perspective and also taking into account social environment. And based on the approach that they have founded on the fundamental rights, 4 ethical principles have been defined. Respect for human autonomy. This is the fundamental right upon which European Union has been founded. Human autonomy and human freedom. Prevention of harm means that AI systems should cause harm or otherwise affect human being. Fairness, development, deployment, and usage of the AI system should be fair and transparent. And should be fair, and explicability means that the processes need to be transparent. The capabilities and the purposes of the AI system should be openly communicated, and the decisions that these systems make, depending on the possibility, explain to those which are directly or indirectly affected. The guidelines then put forward a set of 7 key requirements that AI systems should meet in order to be trustworthy. These requirements are, on the first position, human agency and oversight. What does this mean? This means that AI should empower human beings, allowing them to be informed and to foster fundamental rights. This also means that there should be oversight mechanisms involved, which can be achieved through human in the loop. Technical robustness and safety means that AI systems should be resilient and secure. Privacy and data governance. So this means that beside ensuring full respect for privacy and data protection, we should also have a governance mechanism that will take into account the quality and the integrity of the data that are used. Transparency, as already mentioned, systems need to be transparent. Their decisions should be explainable in a manner that the stakeholders understand them. On the other side, the humans also need to be aware if they are interacting with the AI system on the other side, and they also have to be informed of the system's capabilities and limitations. Diversity, non-discrimination, and fairness must be avoided. This could lead to negative implications from the marginalization on one side of the vulnerable groups to discrimination on the other side. Social and environmental well-being. All this system should benefit all human beings, including also the future generations. And accountability, that means that we should put mechanisms in place that shall ensure responsibility and accountability of the systems and their outcomes. All of the initiatives that have been mentioned from EU, IEEE, or for different governments have one aim, and that is to form ethical frameworks, to prioritize benefits to human society and the environment, and to mitigate the risk and negative impact associated with AI. So what have we done in Atos? We have took into consideration the European guidelines and created our own ethics by design framework. Ethics by design is a multidisciplinary approach to develop intelligent system that has ethics as first principle in the whole solution lifecycle. It combines different kinds of dimensions, like tools to be used, methodologies, governance models, cultural changes, and regulatory compliance. From the initial idea and definition of the use case to the exploitation and operation of the system, ethics should be treated in a similar way like security, like accessibility and privacy. It should be the first principle. We have internally defined several tools to help us in this process, like bias detection and explainability, as well as different checklists to guide us through the defined processes. There are different methodologies, like value-based methodology, that have been adapted in order to create sustainable systems. We believe also that framework like ethics by design should be promoted, supported, and governed by the top management for it to work, with defined ethical advisory board, which will be in charge to enforce ethical principles and oversee frameworks applications in projects. Ethics by design is in Atos aligned with corporate values. In French, we say raison d'être. And multiculturality and diversity is something that we are very proud of and that we enforce. We believe that this framework can provide a solid foundation to address the way we may move wisely to build socially responsible digital intelligence systems. We see ethics not only as a means to comply with regulation or gain acceptance by the society, but we see it as a key contributing factor to create genuine value for all impacted stakeholders. The operational borders and control of digital technology has been well defined and understood until now. But the development in the area of the machine learning, human digital interfaces, digital business models changed also what we can do. Therefore, we are now facing the question, not only can we do something, but should we do it? The potential impact of AI on our society is larger than we have seen now. No technology in history of IT has been so intertwined and embedded in critical processes that impact our lives. Therefore, we must take consideration with what we do, how we are doing it, and whether our actions impact on any human being directly or indirectly. Only by including ethics in the core of our systems can we build future that we can leave to our children. I hope you enjoyed today's discussion and talk, and thank you for your attention.
Thank you, Helena, and everyone. Let's give a warm welcome because we have one more speaker to go for Shift Remote 2020, who's someone I've had the pleasure of introducing before as well. They're a computer science major active in the field of computer vision and machine learning, and in 2014 joined Microblink as a student and has from then helped to transform the company into one of the leading providers of data extraction technology. Let's welcome Mattia Ilias.
Okay, well, thank you everyone for joining this talk on behind-the-scenes development in an AI company. The goal of this presentation is to show you some new development roles that have become crucial when building a high-performing AI company. To start off, I would like to use a short example to talk about behind-the-scenes development in general, and then we can dig into it from the AI perspective. So because it's a very visual display of competitive engineering, let's talk about Formula One racing. So there are many factors that determine which team wins a race. It comes down to drivers, pit stop teams, F1 managers, but the F1 car itself provides some of the most important factors to win. Let's simplify it into two most important parameters, so driving performance and reliability. Driving performance meaning how the car handles in corners and how fast it can go on straight lines, and reliability meaning how long the car can run without breaking down. And these are the parameters that the engineering teams working behind the scenes are trying to maximize. What is usually unknown to those who are not F1 fans is that these behind-the-scenes engineering teams can drastically vary in terms of size and range of work they do, depending on the F1 company. And this is because not all F1 companies have the same resources and expertise, which directly affects what they can build on their own and what they're going to have to buy or lease from someone else. A company can have a very small and compact team to assemble an F1 car with third-party components, but it needs a lot more people and expertise to build most of the components on their own. So why would a company invest to build their own components? So it comes down to our two parameters. Teams building most of the components on their own or tightly collaborating with third-party providers are able to optimize these parameters a lot more than teams using standalone third-party components. And this is because engineering teams that have control over more parts of a complex system, such as an F1 car, have more degrees of freedom when developing a performance-boosting feature. So for the sake of this presentation, let's define behind-the-scenes development. It is not necessarily visible to the outside, and it can drastically vary in size between seemingly similar companies. It requires more resources and more expertise, but gives more room for engineers to push the limits of a complex system. Now let's talk about this from an AI perspective using Microblink as an example. So first, just a brief introduction to Microblink. We are an AI company that builds real-time data extraction technology. The main example of our technology is Blink ID. You point the camera towards your identity document and it seamlessly extracts all of its information. So our clients use it as a powerful solution to pre-fill forms, databases, or onboard users remotely. And Blink ID is a part of more than 500 apps and is used by various web solutions. The same technology has been applied to receipts and is now scanning around 300 million receipts a year to enable advanced market research. The product is called Blink Receipt and has been developed in tight collaboration with our partners in the US. Actually, the first challenge we tackled with AI back in 2016 were handwritten math equations. So this is now a separate company called Photomath that is aiming to revolutionize education. And with more than 30 million active monthly users, they're scanning more than 1 billion math problems each month. And we do business all around the world, and our technology reaches more than 100 million end users. So the data extraction market is our track. And again, our success is dependent on the whole team. But our core data extraction technology provides some of the most important factors to beat our competition. The two most important factors for us are the accuracy and the speed of scanning. Accuracy being a measure of how robust the system can be when extracting data in challenging real-world conditions, and the speed of scanning being the key metric that enables advanced user experience. And these are the parameters that our research and development teams working behind the scenes are trying to maximize. When we take a closer look at our Blink ID product, this is its AI system that performs data extraction. So it connects to a camera and outputs structured information visible on the identity document placed in front of it. And you can see that it's a complex system that consists of many parts. But it's important to point out that the same as in the Formula One example, an AI system can be designed and implemented with a small and compact team using standalone third-party components. And in Microblink, we chose to go the other way and invested heavily in our infrastructure and expertise to build our own components. And this allowed us to squeeze out significantly more performance from our AI system. In the remainder of this presentation, I will be taking you through some of our crucial AI system components and the development roles needed to build them. So let's dive into the details. The system actually consists of several AI models. One question that may arise here is why not train a single AI model? And the short answer is that this is not a straightforward task where current AI models excel, and therefore it makes sense to cleverly design a multi-model system. But the important thing here to note is that we want to maximize the accuracy of each of these models in order to maximize the final system accuracy. So let's have a look at the process of developing one of these AI models. It's a data-driven process, which explains data being in the center. And here we're talking about supervised machine learning, which means we need labeled or annotated data to train and evaluate our models. So this is why the first step in developing an AI model is annotating your data. And the crucial thing to have when building highly accurate AI models is highly accurate annotated data. The principle defined by an IBM developer, garbage in, garbage out, states that computers simply process the data they're fed. And we would add that there are levels of quality here to consider. And for the highest level of accuracy, you need to invest in your own data management system. Which brings us to our first crucial system in the AI development process. So there is much more to annotating data than it seems at first. You need to understand your domain before you start annotating, and our data management system supports our team of domain experts to handle this. As for annotation, it needs to be efficient while providing the highest level of quality. Our system allows us to maximize these parameters to a degree that would be very hard to achieve with a third-party provider. And these have been our conclusions after extensively testing against both crowdsourced and private company annotation services. The development team building this system consists of many important development and engineering roles. So their users are actually data experts and annotators, and they work closely with AI engineers. The system is built with .NET Core microservices using Docker and Kubernetes, and we use different databases for different purposes, and the same goes for front-end frameworks. Okay, so now that we can rely on high-quality annotated data, we can start developing our AI model. So the standard pipeline is to train and evaluate the model on some data, and then if we are satisfied with its performance, we can deploy it. And there are great open source tools to do this. We are using TensorFlow for production and sometimes PyTorch in the research phase. The problem arises when you start doing this on production scale, where currently in our case we are talking about around 15 AI models in production that are constantly being updated on new data. So that's thousands of instances of the aforementioned standard pipeline, and the AI engineers may handle this at first, but as the number of production models rises, this becomes very difficult. I actually took this term production scale machine learning from Google, and there are many other companies offering their solutions to handle this. But for us, it ended up being the same decision as with the data management system. We can go a step further by building our own system. Which brings us to our machine learning engine. So back in 2016, it was very obvious that the open source machine learning tools such as TensorFlow were merely just tools. And we required something that enabled our whole AI development process. So the engine was developed to connect to our data management system, which allows for easier training of our models, but also enables pre-annotation with our best AI models to maximally speed up our annotation. And it also gives our AI engineers a place to build their repository of proprietary neural network layers, architectures, and training procedures. And its goal is to handle the production scale, which includes large-scale model training, evaluation, and automatic deployment of the models. The roles needed to build out this engine are a mix of software and DevOps engineers. They work closely with AI engineers who are actually their direct users. So for development, we use mostly Python with emphasis on TensorFlow, on top of which we are building our engine. And since we are building a machine learning pipeline, there is a lot of novel DevOps tech being used in this process. So now that we have all our AI models trained with the highest possible accuracy, the question is, how are we going to run each of them? And this highly depends on the platforms you wish to deploy the final system on. In our case, we are talking about cross-platform, which means that the best way, in our opinion, is to implement the model inference engine in C++. And again, there are some very good open source solutions for this. Google TensorFlow Lite and Apple's Core ML would be at the top of the list. But back in 2016, when we were deploying our models on mobile phones, those didn't exist. So we started building out our own AI inference engine. And fast forward to 2020, the numbers speak for themselves. So this is our latest benchmark performed earlier this year, and it runs our production AI models across a dozen representative mobile devices. As you can see, we significantly outperform TensorFlow Lite on low-end and mid-end Android devices, and we even managed to outperform Apple's Core ML on their own iOS devices. And a part of that boost in performance lies in the fact that we are optimizing our needs while open source engines are optimizing everyone's needs. And even if we were not faster than the third-party alternatives, it would still make sense to invest in our own inference engine. So firstly, cross-platform coverage is guaranteed, and we do not rely on decisions of companies that have competing platforms. Secondly, control over privacy of the models is something that is becoming more and more apparent as a serious issue. And from our experience, it's very risky to rely on a third-party provider to handle this. Multimodal support, both speed and memory-wise, that makes a world of difference when you are running a whole AI system on device, is another very important benefit. And finally, this gives us a platform to build on top of with our own innovations that can drive new products. So the engine is implemented by C++ developers experienced with hardware level optimizations using the latest C++ standards. But there are also other roles needed to achieve the performance I showed you. One important example to mention is our benchmarking system that is implemented using Python, Rust, and SQL. So now that we have the models trained and ready to run with our inference engine, we have to put it all together to form an AI system that performs a complex task. So each of the models was designed to solve a particular task, and some tasks are handled by processing units implemented by product developers. Also, it is important to have control over the parts of the system where crucial or product-sensitive decisions are made. The problem that neural networks are black box approaches can be alleviated to a degree in a complex AI system if you design it in the right way. And the final system is exported, in our case, as a static C++ library with everything including the AI models compiled in. The team responsible for building this system consists of C++ developers, some of which are very experienced in computer vision. Essentially, they're doing product development with AI models on their disposal. And same as with the previous team, they care about being on the latest C++ standards, and they utilize compile time and meta programming. And this brings us to the last step of our development process. So the deployment of our AI system on both mobile and web platforms. For mobile, one component that has proven to be crucial is our custom camera management system. And this system controls many problematic camera implementations that happen mostly on Android. Our deliverables are SDKs that are developed for iOS and Android, and they are auto-generated using our code generation tools for cross-platforms such as Cordova, React Native, and Xamarin. So we emphasize simple UX with new platform-specific features. On web, we want to offer our technology across all channels. So the AI system is wrapped in a Docker container to be set up on premise or be used as a service. And currently we are working on a new and very challenging in-browser scanning experience where our web product developers are working closely with the inference engine team. And this brings us to the final product that on mobile looks like this. So the user needs to simply point the camera towards its identity document, and the AI system seamlessly extracts all of its data. So there are actually 8 AI models working in parallel in real time to enable this kind of user experience, and it's all done on device. So every step of our AI development process and every system and development role I showed you was needed to achieve this level of performance. If we decided to build our BlinkID product using third-party components, this would be a completely different product in terms of accuracy and speed of scanning. So I hope I showed you that there is a lot of cool development going on in an AI company, and that if you're a developer, there's a big chance you can play an important role in AI. I will be now joining you in chat for any questions. Thank you for your attention.
Mattia, thank you so much. And with that, that brings us to the end of Shift Remote 2020, our 12-part conference, which we've brought to you. Some of the brightest developers online. Has been wonderful, hasn't it just? Let us know there in the chat what you've thought. As ever, use the hashtag ShiftRemote. All that's left to say from me is a massive thank you from all of us here at Shift. Thank you to the team who've worked tirelessly to get all of these conferences up and running, and over to you. Thank you to you all for following us as our friends, as our family, and a huge thank you, of course, to our sponsors without whom this would not have been possible. So thank you once again to InfoBip, Raiffeisen Bank, Microsoft, Autodesk, Microblink, Barrage, Azure Idea, ICT, Japania, Venture, Pseudocode, 5, Ars Futura, Nanobit, Infinium Q, 9 Dots, Get by Bus, Aspira, Code Anywhere, and Pluggy. A huge thank you for making this possible. I look forward to seeing you all online, but that's goodbye from us now here at Shift, and have a wonderful end to your year. Thank you so much. Take care.